Stars are powered by nuclear fusion, a process where the nuclei of two or more atoms are combined to create one or more different atomic nuclei and subatomic particles. The process starts with hydrogen atoms being combined to create helium isotopes. As the star ages, it becomes hotter and allows for more elements to be produced, eventually ending at iron. This iron builds up, and as the star's volume decreases due to age, the density increases. After some time, the star will collapse and create a black hole, as well as a supernova. Because the star collapses, its mass is compressed into an unbelievably small space, giving it infinite density. This is known as a singularity. A singularity is at the center of every black hole. You might be wondering, why are black holes black? We can answer this by using Newton's law of universal gravitation. The force of gravitation is calculated by taking the mass of the two objects, dividing them by their distance squared, and multiplying it by the gravitational constant. Plugging in what data we have on singularities, we see that nothing is fast enough to escape the black hole's gravitational pull, not even light. Because all the light that hits the black hole is absorbed, it is perfectly black, and in the expanse of space, invisible. The event horizon of a black hole is its outermost edge and serves as the point of no return. After this point, the gravity is strong enough to capture anything that enters it. There exists a limit where you can compress any given object into a sphere small enough to make it dense enough to create a black hole. The radius of this sphere is known as a Schwarzschild radius. For example, if I were to compress the entire Earth to become dense enough to form a black hole, it would need to be squished into a sphere with a radius of about 8.87 millimeters. How do black holes die? It may seem like these infinitely dense objects have no death date, but Stephen Hawking offered a counter theory in 1974. Around a black hole, pairs of photons are spontaneously created from its energy and destroyed as they crash into each other and annihilate back into energy. If a pair of photons appears directly on the event horizon, the inner photon cannot escape and gets pulled into the black hole, whereas the outer photon shoots off into space. This will have to occur an incredible number of times for the black hole to lose all of its energy and die. This process is called Hawking radiation.